I feel very privileged that my job allows me to go into the lab and play with making these materials. A bit like a cook in a kitchen. You add a pinch of this and a little bit of that.
The first time that I saw a nanoparticle in an electron microscope, I was hooked for life. I wanted to study these materials down to their atomic level.
The materials that we study and the mechanisms that we study are largely inspired by the process of natural photosynthesis. It is how plants and other organisms take light energy from the sun for their own use. It will transfer that light energy, and then it will use that light energy to create electrons. And it's those different steps along the way that we study in our systems, from which to develop our materials that are easier to work with, that are maybe a lower carbon footprint to work with as well.
A nanoparticle like this, they're capable of doing a few things that from a physicist's perspective are really exciting. They absorb and reflect light in a very unique way. Its properties change dramatically when it gets to the nanoscale. If you take a gold material and you make it very, very tiny, for 5 to 10 billionth of a meter, then gold actually looks kind of red. But I have another vial in which this is also gold, and now gold looks green. And the only difference between these two is that in one case, these are spherical nanoparticles, and in this case, they are triangular nanoparticles. By playing with these kind of physical properties that are kind of unconventional, we can tune the way they respond to visible light.
We get to work with very colorful materials. My curiosity comes from the possibility to make something brand new, and then we can characterize what's happening with them using our laser experiments. It's always very exciting when a material does something that we designed for it to do. But sometimes what's even more exciting is when it does something unexpected.
The reason we study these tiny objects is also because they have a lot of surface. And surface is where the magic happens. These nanoparticles are capable of taking this visible light and essentially compressing it into their surface. They can convert the energy of light into electrons. And these electrons can then be used to drive chemical reactions. And so you have chemical reactions that use light as a source of energy. You can get phenomena that are very exciting in terms of energy conversion and sensing.
The more we can understand about the fundamental mechanisms of how these materials convert light energy, and the more doors we open to realize unforeseen applications with these materials.